So the Department of Planning, Transport and Infrastructure came to us with a stormwater issue, which was basically a blockage of a pipe that was running underneath a very deep embankment in the Mitcham area, which after every storm event would block and then cause water to run through the embankment, scouring the embankment and potentially causing its failure at some point in time. So the issue that we were trying to resolve at this location was we have a 30-metre high embankment with a single drainage pipe at the base of the embankment, which is only 450 millimetres in diameter, which is very small considering that there's a natural waterway feeding into that one pipe. There is no trash rack or any sort of catchment for debris that might be coming down that area. So very quickly that pipe silts up with debris and blocks, forcing water through the embankment, the base of the embankment. The work that we were required to do was to construct a gabion wall that would basically form a weir, which would hopefully capture a lot of that debris that's coming back and protect the inlet of the pipe from silting up or blocking, allowing water to pass through the embankment freely. Well, there's a range of issues. The first one is that there are two rail lines running concurrently, and they're owned by different operators. So you have the Department of Planning, Transport and Infrastructure who own one line, which is the Metropolitan Rail line, and then you have the ARTC, which runs the freight lines from Melbourne to Adelaide. They're both basically running across the same area, so there are two stakeholders involved, which is the first problem. The second issue was just access to the site, which there was no direct access to it, and the actual work area was 30 metres down from the actual rail level. So there was an issue in getting materials and plant equipment and personnel down into the area to actually physically do the work. Initially we were looking at the conventional options of trying to crane machinery down into the actual bottom of the valley to do the work. The first alternative option we looked at was helicoptering in or airlifting in equipment. We'd never done it before. We didn't know if anyone had done it before. So our initial reaction was to Google it. And that's what we did. We Googled airlifting of earth moving equipment. And that's where we came across a potential supplier of a service to actually help us perform that task. Well, the process itself involved really assessing what machinery we were going to be putting into the valley floor, so we could then discuss with the helicopter supplier weights and the potential for their equipment to actually perform what we needed to perform. Obviously it's very difficult to lift in a very heavy piece of machinery, so we then looked at alternatives around what smaller machines we would need and how many of them we would need in the space that we had available to actually physically do that work. Yeah, we were all a bit anxious and we were all a bit excited about, we were all positioned in different parts to get footage, and when the helicopter came through it was all pretty exciting. We didn't really know exactly what to expect from this machine and how easy or hard it would be to perform the task that we had to perform. And all the planning, I guess, and the professionalism of the supplier that we had used for the airlift really came to fruition on the day, and it went pretty much without a hitch. Very professionally done, very seamless in the way that the process happened. Look, there were a lot of stakeholders involved in this project. Davison Earthmovers, obviously as the project manager for this job, really went out of our way to make sure that we had covered off all of the risks associated with the actual process. And because of the way that we'd planned this process over a 12-month period, it really lent itself to the actual process happening very seamlessly, efficiently, and without fuss. Well, aside from lifting the equipment into the actual valley floor, there were other logistical issues around getting material into this location. For example, we had, I think, around 300 tonne of stone that needed to be supplied to the job. We had no way of lifting that stone onto the valley floor, so we had to come up with innovative ideas of how to get the material down there without being contaminated and in a suitable quantity that could actually complete the work. The wall construction was more than just a wall, I guess. There was a wall and associated rock lining to prevent scour and force water into certain areas to make water, I guess, behave in a certain way and send debris to certain areas so that it could be managed long term. Yeah, so on completion of the work, we knew that the client was happy with the finished product. We were all sort of waiting for some rain to see how it would perform in real life. And luckily, about a week after we'd completed the work, it did actually rain. and water did flow through the actual catchment area towards the weir, and the weir worked perfectly, exactly the way we had expected it to function. The Department of Transport took some photos of the weir in operation, and it just basically performed exactly the way we had expected it to perform, retaining the debris that was coming down and just allowing clean water to flow through the pipe.